Okay, we'll get back to section 3.2 here. We'll talk about just another method for graphing parabolas is using transformations. Okay, it says that sometimes a quadratic function is written in the form f of x equals a times x minus h squared plus k, in which case we prefer to use transformations on y equals x squared. Okay, we're always going to make four graphs when we use this method, and the last graph is always going to be our answer. Okay, so here's what's going to go on these four graphs. So the first graph is always going to be the graph of y equals x squared. You're going to graph the parabola, and I always label these 5 points here: 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. Just because you're going to be moving these points around, and you got to keep track of where things are going there. Okay. Number 2, so you're going to graph y equals a times x squared by multiplying each y coordinate on the graph of y equals x squared by a. Okay. And just as before, the value of a is going to tell you if the parabola is going to open up or down. Okay, depending on if that's a positive or a negative number. The third thing is going to be a shift to the left or to the right of graph 2. Okay, you're going to graph y equals a times x minus h squared. So you shift this graph to the left or the right, h units. Okay, number 4, so the fourth graph is going to be our answer. And that's where we're going to be graphing y equals a times x minus h squared plus k. In the last graph, you're going to shift up or down k units, depending on the number for k. Now the vertex is going to be at the point hk, which is why they call this vertex form, by the way. Okay, so let's take a look at problems 4 through 6. We're going to graph each quadratic function using transformations. Write the equation below each graph. Okay, so here's the first graph. I got y equals x squared. Again, I always label these 5 points. So if x is 0, y is 0. If x is 1, y is 1. If x is negative 1 squared is 1. If x is 2, 2 squared is 4. If x is negative 2 squared is 4. Okay, and go ahead and draw the parabola. So the first transformation, or our second graph, is going to be where we're taking care of the a value. For us, that's a 3. Okay, so I'm going to have to graph y equals 3x squared. Y equals 3x squared is going to be a vertical stretch from the graph of y equals x squared. And all I'm going to do to get the new graph is I'm going to multiply all the y values on y equals x squared by 3. Okay, so let's do that. 0, 0 is going to stay at 0, 0. 1, 1, when you multiply the y value by a 3, that'll put you at 1, 3. Negative 1, 1, when you multiply the y value by 3, that'll put you at negative 1, 3. 2, 4, when you multiply the y value by 3, that'll put you at 2, 12. And negative 2, 4, when you multiply the y value by 3, that'll put you at negative 2, 12. Okay, both of those points are off the scale that I've got here. That's fine. That sometimes happens. We'll stick with these 3 labeled points the rest of the way. Okay, and I stretched out the graph of y equals x squared. So if I imagine hands pulling on the vertical axis, stretching this graph out, that's going to force the parabola to get closer to the y-axis on both sides. Okay. Now graph 3 is always going to be a shift to the left or to the right of graph 2. So I need to graph y equals 3 times x plus 1 squared. Okay, I'm going to be shifting the graph to the left 1, because that's a plus 1. And so all these points, just bump them to the left 1. Okay, so 0, 0 is going to be at negative 1, 0. 1, 3 would be at 0, 3. And here's negative 1, 3. That's going to be at negative 2, 3. and then draw the parabola. Okay, and I'm writing the equations of each graph below the graph also. The last graph is our answer, okay? And you're going to shift up or down k units. K is 2 here. So we're going to be graphing the whole curve now. Y equals 3x plus 1 squared plus 2. Okay, so because I got a plus 2 there, I'm going to have to shift graph 3 up 2 units. Okay, so let's go ahead and do that. Negative 1, 0 is going to be at negative 1, 2. 0, 3 would be at 0, 5. And negative 2, 3 would be at negative 2, 5. Okay, and then I draw the parabola, and that's my answer. That's the graph of this curve here. Okay. Let's now, and by the way, so the vertex is at the point HK. Now that's something that I could already know right away before I did any graphing. So the vertex here would be at negative 1, 2, so it's x minus h squared. So the way to look at this is you got x minus a negative 1, the same as x plus 1, and then the k value is 2. Okay, so, you know, like in my answer here, if I'm not landing at the point negative 1, 2 for the vertex, and if the parabola is not opening up, you know, I did something wrong. Okay, and so we have both those things there. That looks good. Let's try problem 5 there. Okay, so we're going to graph f of x equals negative 2 times x minus 3 halves squared plus 1, using what we know about transformations. Okay, now the vertex is going to be at the point 3 halves 1. Okay, so in my answer here, if I'm not landing at 3 halves 1 for the vertex, something went wrong. Also, this parabola is going to open down, right? Because there's a negative 2 in front of the x minus 3 halves squared. Okay, so the first graph is going to be the graph of y equals x squared. Here's that graph again. The second graph is y equals a times x squared. A is negative 2. So I need to multiply all the y values by negative 2. Okay, 0, 0 is going to stay right at 0, 0. 1, 1 is going to go to 1, negative 2. Negative 1, 1 would go to negative 1, negative 2. 2, 4 is going to be at 2, negative 8. And negative 2, 4 is going to be at negative 2, negative 8. Both those points are off the scale that we've got. Again, that sometimes happens. Okay, so we'll just stick with these 3 labeled points the rest of the way. Okay, and that's just, so I draw the second parabola there. Because I'm drawing parabolas, I don't want any sharp turns here. Okay, so make sure there's a nice smooth turn going through the vertex. Okay. The third graph. Okay, we want to graph y equals negative 2 times x minus 3 halves squared. All right, so the third graph is always going to be a shift to the left or the right of graph 2. In this case, we're going to be shifting to the right 3 halves units. Okay, so all these points, bump them to the right 3 halves units. All right, so 0, 0 is going to be at 3 halves 0. 1, negative 2 is going to be at 5 halves negative 2, or 2.5 negative 2, same thing. And then negative 1, negative 2 is going to be at 1/2 negative 2. Okay, and then go ahead and draw on the parabola there, passing through those 3 points. And the last graph is my answer. Okay, so that's where I need to be drawing the whole curve now. Y equals negative 2 times x minus 3 halves squared plus 1. Okay, the plus 1 means I'm going to have to shift graph 3 up 1 unit. Okay, so 3 halves 0 is going to be at 3 halves 1. 5 halves negative 2 is going to be at 5 halves negative 1. 1/2 negative 2 is going to be at 1/2 negative 1. Okay, And I draw in the parabola there. So this graph would be my answer. Okay, and yeah, just as I said, so the vertex is at the point 3 halves 1, right? H is 3 halves, K is 1. I could know that before I even did any graphing, that's where the vertex is going to be. And also I know that this parabola is going to open down. And that's exactly what happened. Okay, try problem 6 here next. So in problem 6, we have the function f of x equals 1/2 times x minus 1 squared minus 2. Okay, so the first graph is y equals x squared. I've got that. And the second graph is y equals a times x squared. The a value is 1/2. By the way, the vertex would be at 1, -2. Okay, so if I'm not landing at 1, -2 in the end here, something went wrong. Okay, a is 1/2. Okay, so what that means is that I need to multiply all the y values by 1/2 to get the new graph. Okay, so 0, 0 is going to stay at 0, 0. 1, 1 is going to be at 1, 1/2. -1, 1 would be at -1, 1/2. 2, 4 would be at 2, 2. And -2, 4 would be at -2, 2. Okay, so we draw the parabola. And in this situation here, I've got a vertical compression of the graph. So I know that the graph is going to split further from the y-axis on both sides. You know, if I imagine hands pulling on the y-axis, smashing this graph together, then that's going to, you know, force the parabola to split further from the y-axis on both sides. Okay. Graph 3 is where I'm going to graph y equals 1/2 times x minus 1 squared. Okay, so with the x minus 1 there, I know I'm going to have to shift graph 2 to the right 1 unit. All these points there. Okay, so let's do that. 0, 0 is going to be at 1, 0. 1, 1/2 is going to be at 2, 1/2. -1, 1/2 would be at 0, 1/2. 2, 2 is going to be at 3, 2. And -2, 2 would be at -1, 2. Okay, so then I draw the parabola. The last graph is my answer. And so it's going to be y equals 1/2 times x minus 1 squared minus 2. Okay, so the minus 2 means I'm going to have to shift graph 3 down 2 units. Okay, so if I do that, 1, 0 is going to go to 1, -2. That looks good, right? Because we said that the vertex is at the point 1, -2. Okay, and then 2, 1/2. That's going to be at 2, -3 halves. 0, 1/2. When I go down 2 units, that'll put me at 0, -3 halves. And then 3, 2 is going to be at 3, 0. -1, 2 is going to be at -1, 0. So then I draw the parabola passing through those points there. Okay. So, you know, keep in mind that this form here is a parabola. Okay. And, you know, one nice thing about being in this form is that you already know what the vertex is. So there's no calculation like we saw over here where it's -b over 2a, f of -b over 2a. No, we don't have to do that. Okay. So that is one advantage of being in vertex form, I guess. Okay. We'll go ahead and stop the video right here, and we'll look to wrap up this section in the next video.